Okay, this is our second session. Okay, there was a catch somewhere that people didn't see, right? Hence, yeah. I said earlier on here, I said that if, or did I actually say it, or I said it in my head? Oh, okay, I kind of said it in my head. But yeah, I kind of, no, not necessarily, but yeah, I said if you find there is a square root already and you just substitute, you're not expecting to get a negative number, right? You're not expecting to get a negative number. What does that mean? It means when you come in here and doing your check, when you put your 1 there, you're only expecting a positive number, right? You're expecting just positive 1. You know, even here, when you come here, you're expecting just positive 3. And therefore, what that does to this particular question, it leaves this particular question with just one solution, which is x is equal to 3. But the other one is not a valid solution. This is not a valid solution. Right? Are we happy?
Yes, sir.
Now that one is please note that, guys, please note it. I think I did choose a bit difficult example to sort of like, because it had 2 elements in 2. You know, it has the fact that you have to check and the values might not be the same. And it also has the idea of if you already find a square root there and you're substituting, then it's different to when you are taking a square root yourself, you know. I was going to make 2 examples, but I don't think anything is going to change. Just want to say that you could have a situation whereby both the solutions are valid. You could have a situation whereby none of the solutions are valid, right? After all, it's a quadratic. If that quadratic doesn't have a solution, then you wouldn't necessarily have solutions. Okay, moving forward. Let me look at case. Let me look, that's 2 things. Let's look at case 5. Case 7. Case 7 is what I said is K method, right? Someone giving you a chunky thing and you're just like, wait. How do I start here? Then you sort of like do a case substitution. Let's go for it, right? Likely to just make 1 examples and just see where people are at. But these ideas, they are all important. Case substitution doesn't have a lot in it. It's a form of simplification. So it doesn't like have a lot of explanation that I have to sort of like give. So suppose that you have x squared plus x plus 4 plus 8 over x squared. Let me write this more in a way that actually, let me say 8 here. And then say x squared plus x plus 4, or maybe plus 2. We just do this. Minus 2 and x plus 2 here. Okay, now look at that, and that is set to be equal to 0. Now let me just tell you, if you were to go forward and think about this particular expression as over 1, or maybe let me just do this. If you were to think of this as that term and that term, and you think about that expression over here as just over 1, and you just want to multiply by this x squared plus x plus 2 throughout, it's a disaster, because once you've multiplied that, you're going to get your highest degree would be 4. That would be the highest degree, which means now you have to solve an equation that has x to the power 4, which is sort of like difficult. You guys haven't even done cubic functions now. Some of you have, and they already know the pain of trying to solve cubic functions or cubic equations. It's much more when you try to solve those problems like that. So we therefore have to have a different approach. We need to look at what could be repeated in this term. So if you look here closely, you will find that x squared plus x, and you have it there, but you also have it there. So it's kind of a repeated expression. So that repeated expression, you let it equal to 0. So, sorry, you let it equal to k, right? So I want you to note the following: x squared plus x is repeated. Is repeated. So if that is repeated, you can say let x squared plus x be equal to k. And look at how your expression simplifies. It's going to be now, if you take that expression, it's now going to be k minus 4 is equal to 8 over k plus 2. Are we happy? And then now you can, if you want, remember, if you have that, you can either, there's a lot of things that you can do. You can either cross multiply, or you can just do what we've been doing. Maybe let me just, so you're going to look at the denominator of that and the denominator of that. That's k plus 2 times 1, and there's nothing repeated. So actually our equation is going to be multiplied by that, k plus 2, basically. So we're going to take that equation and just multiply it by k plus 2. If we multiply the whole entire thing by k plus 2, we're going to have k minus 4 is equal to, k minus 4 times k plus 2 is equal to 8 over k plus 2 times k plus 2. Such that that and that are done. And then what you have k squared, right, minus 2k minus 8 is equal to 8. We're happy? Am I right?
Yes, sir.
Something doesn't seem right. Yes, you guys, I made a big mistake. Okay, let me show you my mistake. That I forgot to note that this was before the equal. I just put it on the other side without, and it looked okay, but it's not. Okay, so let me just solve that and then I'll come back to how would this look like. Okay, so it's very important that you guys look at what I'm doing. So this would now be 8 over k plus 2. However, we're still going to multiply our equation by k plus 2, and we know how that came about. So this is going to be now k minus 4 times k plus 2 plus, if I multiply this by k plus 2, it's going to cancel. So I'll just have 8, which is equal to 0. Now, if I solve that, I'll have k squared minus 2k minus 8 plus 8, like that. It's equal to 0. And what I would just basically have there is k squared minus 2k is equal to 0. So what I would pretty much have there is just k and k minus 2 is equal to 0. So what I will have is k is equal to 0 or k minus 2 is equal to 0. However, I need to note that that's not what I was solving. I was solving for x. So I must come back to these final equations of k, or values of k, and substitute what x is, or what k was rather, what k was. K was x squared plus x. So I need to come here and say k was x squared plus x equal to 0. And k was x squared plus x minus 2, like that. So now I can start solving what x is. I can take out a common factor. That's what I would have. So my x is equal to 0, or my x is equal to -1. On the other side, I can do factors. As I've said, this is an application. As to how you solve this, it's up to you. But yeah, this is going to be x, yes, those would be +2 and -1. And that would give me x is equal to 1, or x is equal to -2. Now, you guys have, these are the values of x, but I just want you to just remember that I said, if you had multiplied this out, your highest power would have been x to the power 4, which means that you would have x1, x2, x3, x4, 4 solutions of x, which is what we have. We have 1, 2, 3, 4. So we do have four solutions. Now, this idea came with a guy called Pascal, right? He basically said, if your highest degree is 1, you're just going to have 1 solution of x. He said, then if your highest degree is 2, like a quadratic equation, you're going to have 2 solutions of x. You know, you'll have your x1 and you'll have your x2 being whatever. And then if you have 3, which some of you guys have seen, you have to have 3 solutions of x. Sorry, that's 2. That's x3 is equal to c, which is pretty much what we're seeing here, where we had 4. So this is like a simplified version of of solving functions of equations of x to the power 4. So yeah, that's it, guys. This is the end of quadratic equations, right? Now, everyone that I've done quadratic equations with, I always told them that I'll just do what is necessary for you to go forward. But I mean, this is the whole pack of what quadratic equations look like, right? This is the whole pack of what quadratic equations look like. Now, I did do one example, but I mean, I can give you homework. Let's look at the homework. The homework, can I give you something like, I do feel like giving you something that's mixed up, like, okay, maybe anyway, let me just give you one problem that just deals with this. Let's say it's, let's give you 12 divided by 3x squared plus 7x plus 2. And then having that being a plus 3x squared plus 7x is equal to 6. Let's have that. Or let's have something a bit different to what I did. 3x squared plus 2x that squared. Remember, you always look for the repeated part of the equation. 3x plus 2. Yeah. And then let's give you some nice third questions. A is equal to 2 minus 2a minus 5, and also maybe give you another one where perhaps you have something like 4 square root P minus 2 is equal to P plus 1. All right, okay, let's have those ones for homework. Anyone can do them. Everyone must kind of do them, which is good. But yeah, one person who's literally has to do them is Luvuyo. But it's a great benefit, guys. It's a great benefit. Okay, that's it from me. Do I have any questions, guys? Do you guys have any questions? Okay, that's it from me. Guys, have a great evening. Having a class just in 10 minutes. I'll see you guys in the, I'll see you on Monday. Oh, sorry, I'll see you on Tuesday, right? I'll see you on Tuesday. Today is the Thursday. It's the last class of the week. I'll see you on Tuesday. Okay, cheers.